4 ohm. So it will be much easier for us than the theoretical one. Okay, let's calculate first what is the current in this circuit. Plus, minus, plus, minus. So what is I is equal to? E by R plus R. Directly I am writing it. This is 5, 4 plus 1, 1 ampere. Let's calculate terminal voltage. So terminal voltage, we do write like this, no? VA minus E plus IR minus VB equals 0. So VAB equal to E minus IR. This should be equal to 4 volt. Let's power generated by cell. This should be equal to E into I. So E is how much? 5. I is how much? 1 ampere. 5 watt. For every 1 second, 5 joules will be generated. What is the power dissipated by the cell itself? That should be equal to I square R. What is I? 1 square. R is 1 watt. Power available across the external circuit. That should be equal to how much? I square R. 1 into 1 square into 4. Now I think things are very clear in front of you. Tell me, like, this is something lost, no? Where inside the cell itself, this much 5 watt it will generate, of which 1 watt will be taken by the cell itself. How much is made available? 4 watt. So tell me, like, what do you expect internal resistance? Should be more or less to improve the efficiency of cell? Should be internal resistance should be as less as possible. If small r is less, if there's some 0.1 ohm, small r equal to, if this internal resistance is 0.1 ohm, then this PR will be less, no? This will be less. Then more power will be made available to external circuit. So therefore, this is the power generated by cell, power dissipated by cell. This is the power available across the circuit. So here what we say now, if a current I leaves a cell, then we say it is discharging. We'll call this cell as charging, or supplying energy to circuit. Discharging you have to call, because it is supplying energy to circuit. Discharging or supplying energy to circuit. So this is what the power generated by cell. Now what you call should this one? Power dissipated by cell. Dissipated, it's over. Permanently lost. Power dissipated by a cell. This is what? Power supplied to external circuit. So when it's discharging means it is supplying energy to circuit here. Similarly, we'll go for this overall mechanism. So therefore, what is that internal resistance offered by the material of cell to the flow of charge? So what is actually overall phenomenon it occurs? Overall working, sir, how to you just summarize? So I'll switch on the cell. Then what happen here? The cell does work. So because of work done, what happen? It will lift the positive charge from negative to positive terminal. For that, it has to do work. No, see, go back to electrostatics. On its own, a charge can move from low to higher potential. Not possible, no? The positive charge can move from high to lower potential. So therefore here, somebody should help. The energy available due to reaction weapon will lift the charge from low to higher potential. That energy is given to the charge now. With that energy, the charge will go around the circuit. Here it encounters a resistance. It will give out that energy to overcome that resistance. Finish over. Then what happens once energy becomes zero, it will be attracted by the negative terminal. Then again what happens? The charge will be different. During its flow inside the material, the resistance of material, what it does, it will exert a force. It will oppose the motion of charge. So what the resistance will do of the material will oppose the flow of charge across the cell. So therefore that is called an internal resistance. And what it will do, it will oppose the flow of charge. So therefore that R is brought here, this one. So definitely what happens, a cell what happens, when it is transferring charge across B to A, it should overcome this resistance. So what do you expect? This R should be low value or high value? It should be, if it is as low as possible, it's a very good cell. If it's a high value, if you buy some Chinese products, no, this will be very large. That's why you see some, when you buy the Chinese mobiles, they say like, it will eat up soon. They say it will eat up. So I think now you can experience that eating up here. So when you go for this Zoom class for 2 hours, your mobile will be very hot. No, any reason for that? The internal resistance. So if you buy the some Apple or some good Samsung, good quality mobiles, no, that one, then what when the internal resistance of cell or the mobile will be so designed that this as minimum as possible, then less heat will be generated in the equipment. That's why you look at the television, mobile, laptop. So what is all electrical equipments? They must have less internal resistance. If this internal resistance is more, it will damage. Very soon what happen? The equipments open, the lifespan of that will decrease. So when you're purchasing the laptops, mobiles, so what is priorities? You have to somebody saying my phone or room heater. I don't know much about that phone. Maybe most of the Chinese mobiles, what happen, they offer for low price, but where do they compromise? They compromise on this. So what type of material they should use? They should use very high quality material. It will offer less resistance to the flow of charge. Definitely cost will increase. Definitely cost will increase. So this what happens here. So this should be as low as possible. A good cell, it should be that you see that we do when you purchase any remote car, no, some inbuilt recharge cells will be there. But you purchase Duracell, Eveready or Nipo, that means they will work better. The reason for that, the internal resistance. So as you go for a little bit higher price, no, the internal resistance will become minimum, and the performance of cell will be very good. That is about the theoretical background. So numericals will be very easy for you. Just you should have the numericals what I discussed, no, will be of this kind.